From the beautiful flowers to a perfect captured photos, Fibonacci sequence plays a major role on how we see and perceive our world. This mysterious sequence appears all around us in nature, arts, science, and mathematics, and somehow and somewhat might the key and the answer to the questions of the universe.
Hi, I'm Leonard M. Canja, a freshman student from Chemical Engineering Department, and you're watching Math Made Easy. And for today's episode, we're gonna talk about Fibonacci sequence.
Fibonacci sequence is a sequence where its first two terms are 0 and 1, and each term thereafter is obtained by adding the two preceding terms. The first two terms of Fibonacci sequence is 0 and 1. Let us determine the next few terms by adding the previous two. 1 plus 0 is equal to 1. 1 plus 1 is equal to 2. 2 plus 1 is equal to 3. 3 plus 2 is equal to 5. 5 plus 3 is equal to 8. 8 plus 5 is equal to 13, and the sequence continues. The first term of Fibonacci sequence is denoted by f sub 0. The second term is f sub 1. The third term is f sub 2. The fourth term is f sub 3. And the fifth term is f sub 4, and the pattern continues. We have the first 8th term of Fibonacci sequence. Let us determine the 9th term. To determine the 9th term, or f sub 8, we need to add f sub 7 and f sub 6. F sub 7 is equal to 13, and f sub 6 is equal to 8. 13 plus 8 is equal to 21. So what if we are looking for f sub n, or the nth term of Fibonacci sequence? First, we need to add f sub n minus 1 plus f sub n minus 2, where f sub n minus 1 is the previous term, and the f sub n minus 2 is the previous term. The Fibonacci sequence is claimed to have been created by Mr. Leonardo Pisano Bigoglio, or known as Fibonacci, in the early 13th century, although it was known long before by Indian mathematicians around the 60th century. Either way, the Fibonacci sequence, as it's now called, has captivated mathematicians and artists alike for its beautiful relationship to the constant of pi, or its aesthetic nature. It was first discovered from the problem of solving how many rabbits can reproduce. Suppose a newly born pair of rabbits, one male, one female, are put in a field. Rabbits are able to mate at the age of 1 month, so that at the end of its second month, a female can produce another pair of rabbits. Suppose that our rabbits never die, and that the female always produces one new pair, a one male and a one female, every month from the second month on. The puzzle that Fibonacci posed was, how many pairs will the newly born pair of rabbits in a field? So we have one pair of rabbits. At the end of the first month, they mate, but there is still only one pair. At the end of the second month, the female produces a new pair. So now there are two pairs of rabbits in the field. At the end of the third month, the original female produces a second pair, making 3 pairs in all in the field. At the end of the fourth month, the original female has produced yet another new pair. The female born 2 months ago produces her first pair, also making 5 pairs. And the pattern continues. As you observe, the number of pairs 1, 1, 2, 3, 5 are the first term of Fibonacci sequence. Amazing, right? Okay, let's move on. How to find the nth term of Fibonacci sequence? Let me teach you. Let's test your wits. What is the 30th term of this Fibonacci sequence? You can pause the video to solve it. The first 8 terms of Fibonacci sequence are given. We can determine the 30th term if we continue the pattern. The next term, 13 plus 8 is equal to 21. Next is 21 plus 13 is equal to 34. 34 plus 21 is equal to 55. 55 plus 34 is equal to 89. 89 plus 55 is equal to 144. And the 30th term is equal to 144. Another way to solve this for the nth term of Fibonacci sequence is by using a formula. Since Fibonacci sequence is strongly related to the golden ratio, we can use the Bennett's formula. If we are looking for the 30th term, we can substitute 13 to the n in this formula and simplify.
That's it. I hope you enjoy and learn something in this video. To learn more about Fibonacci sequence, just visit math.temple.edu.com. Once again, this is Lenard M. Canja, and you're watching Math Made Easy.